Hello and welcome to our 6.3 summary video part 2. We're going to start off by recalling how to identify trig functions from a right triangle. So I'd like you to pause the video now and see if you can complete this first example on your own. So our 6 trig functions are sine, cosine, tangent, and then our reciprocals. Reciprocal of sine is cosecant, reciprocal of cosine is secant, and tangent is cotangent. So in order to find our ratios for our angle theta, we need to make sure we have all 3 sides of our triangle. So I'll start by using our Pythagorean Theorem to go ahead and find this side, which I'll call b. So 4 squared plus b squared is equal to 12 squared. 16 plus b squared equals 144, which means that b squared is going to be equal to 128. So b is equal to the square root of 128, which simplifies down to 8 times the square root of 2. So this horizontal distance is 8 rad 2. Since we are not in a coordinate plane, we're not worried about whether our x value is positive or negative. We're just talking about a distance here, so the length of that leg is 8 rad 2. So then sine, if we're looking at our angle theta, we've got 2 legs to pick from. The opposite leg from theta would be 4, and the adjacent leg, or the one that's touching theta, is 8 rad 2. The hypotenuse is always that third side that's across from our 90-degree angle. So sine, the opposite leg, is 4 over hypotenuse, which is 12, so sine is 1/3, meaning that cosecant is the reciprocal, 3 over 1, or 3. Cosine is the adjacent leg, so 8 rad 2 over 12. I can reduce this by 4 to get 2 rad 2 over 3. Secant would be the reciprocal, so 3 over 2 rad 2. We could rationalize this to get 3 square root of 2 over 4, but we're not going to worry about going through that process now. Tangent is opposite, which is 4 over adjacent, which is 8 rad 2, which simplifies down to 1 over 2 rad 2, and cotangent would be the reciprocal, so 2 square root of 2 over 1, or just 2 square root of 2. We're going to move on into determining the value of the remaining 5 trig functions given one trig value. So what this means is that I've got an angle theta. The angle theta has an opposite side that is 4 and a hypotenuse that is 5. And I know that just based on the ratio 4 over 5. I know that sine is the relationship between the opposite and the hypotenuse of my triangle. So that means that from theta, the opposite side is 4 and the hypotenuse of my triangle is 5. So I'll go ahead and put theta in this angle here. It really doesn't matter where. I'm just going to set up my triangle so I have a picture of what's happening. So from theta, that opposite side is going to be 4, so my opposite leg would be directly across from theta, so this length is 4. Hypotenuse is always across from my 90-degree angle, which means that this length is 5. So then to find the remaining 5 trig functions, I am looking for cosecant of theta, I'm looking for cosine of theta, and its reciprocal secant of theta. I'm looking for tangent of theta, and I'm looking for cotangent of theta. So I know that cosecant is the reciprocal of sine, so cosecant is going to be 5 over 4. To find cosine, I need the adjacent side over my hypotenuse. So I'm going to go ahead and find the length of that adjacent side now using the Pythagorean Theorem. I'll call this side b. So using my Pythagorean Theorem, 4 squared plus b squared is equal to 5 squared. 16 plus b squared is equal to 25, which means that b is equal to 3. So this length for b is equal to 3. So now my cosine has an adjacent side of 3 and a hypotenuse of 5. Secant is the reciprocal of cosine, so 5/3. Tangent now I can fill in is the opposite side, which is 4, over the adjacent leg to theta, which is 3. And cotangent is the reciprocal, so 3 over 4. All right, your turn. Go ahead and pause the video and practice this next example on your own. I know that tangent is the relationship between the opposite side and my adjacent side, so I'm going to go ahead and set up a triangle, putting theta in one of the acute angles of my right triangle. The opposite side from theta is going to be 8 square root of 3, and the adjacent side will be 13. So from here I'll use Pythagorean Theorem then. I'm looking for the length of my hypotenuse. To find the length of my hypotenuse, I know that h squared is going to be equal to the sum of the squares of the legs, so 8 square root of 3 squared plus 13 squared. So 8 times the square root of 3 squared is going to be 64 times 3 plus 169. 64 times 3 is 192 plus 169. 192 plus 169 is 361. So h squared is 361, which means that h is 19. So the length of this hypotenuse is 19. So then I'm looking for the sine of theta, secant of theta, cosine of theta, cosecant of theta, tangent, which I already have, and cotangent of theta. Sine is the opposite leg, which is 8 square root of 3 over 19. Secant is the reciprocal of cosine. I'm actually going to go ahead and do my cosine first. So cosine is adjacent 13 over 19, which means that secant is 19 over 13. Cosecant is the reciprocal of my sine function, so 19 over 8 rad 3. Tangent we already have, 8 rad 3 over 13, and cotangent is the reciprocal, so 13 over 8 rad 3. We're going to move into our trig functions in the coordinate plane. So determine the value of each of the following trig functions. I've got an angle of 300 degrees and I would like to find the cosine value of that angle. So in my coordinate plane, I start with my initial side of my angle on the positive x-axis, and then I swing around that terminal side 300 degrees, which would be just after 270 but before 360. Now we've only talked about trig functions as parts of a right triangle, so in this angle I can't create a right triangle from that 300 degrees. However, what I can do is I can now take this terminal side and connect it back to the x-axis. And instead of looking at that 300 degrees, what we're going to look at is instead the reference angle, which is the acute angle between my terminal side and the positive x-axis. And I'll use this angle to help me determine the value of my cosine. So if this angle is 300 degrees, then I go another 360 degrees to get back to that x-axis, which means that my angle inside this triangle is 60 degrees. So I have a right triangle with an acute angle of 60 degrees, so what I really want is the cosine of 60 degrees. So I will use special right triangles to help me determine the value of my cosine function. So in a 30, 60, 90 degree triangle, the shortest side across from my 30 degrees, which would be the angle in that bottom right corner, is going to be A. That middle length side is going to be A times the square root of 3, and the hypotenuse is 2 times A. The hypotenuse is just a length, it's not a direction on your coordinate plane, so that diagonal component is just a distance. However, when we're talking about this horizontal length A, we are talking about a distance along the x-axis. So what we're actually referring to is what is this point right here on our x-axis, and that's going to be a positive value of whatever A is. If A is 5, then this point is positive 5 on my x-axis. Similarly, this vertical component is going to have a negative y value since we're down in that lower right region of my coordinate plane. So that means that this distance, a square root of 3, will give me a negative y value. So I'm actually going to talk about this as a negative a square root of 3. We're not talking about distance here. We are talking about the value of the y coordinate at that point. So my cosine then of this angle is going to be the adjacent side, which is a, over my hypotenuse, which is 2a, giving me a positive cosine value of 1/2 when I reduce my a's. I'll go ahead and repeat this process with sine of 225. So sine of 225, I start with my angle on that positive x-axis, and then I rotate around to the terminal side, which will be just after 180 degrees, to give me 225 degrees. Now again, 225 degrees is too large of an angle for me to look at a right triangle with, so I use the reference angle instead. The reference angle just means I draw a right triangle with the closest x-axis. If that whole angle is 225, then that missing piece, that acute angle inside my right triangle, is going to be 45 degrees. And I get that because it takes me another 45 degrees to get from 180 to 225. So using my ratios of a 45, 45, 90 triangle, I know I've got a, and then a times the square root of 2. This diagonal distance is always positive, but in that third quadrant, my x values are all negative. So this point on my x-axis has a negative value, and this point on my y-axis, determining the end of that segment for the vertical component of my triangle, is also negative, meaning that my y value will also be negative in that third quadrant. Sine is opposite over hypotenuse, so my opposite leg is negative a, and my hypotenuse is a square root of 2, which simplifies to negative 1 over the square root of 2. Go ahead and pause the video and see if you can finish those next 3 on your own. For cosine of 150, we would be using a reference angle of 30 degrees. So that reference angle of 30 degrees would give us a cosine value of 1/2. If I have this as a and this as a times 2. Cosine of 315 degrees, I would be looking at an angle in this fourth quadrant, which would take me 45 degrees to make my right triangle. Cosine then would be 1 over the square root of 2. I would have a leg of a, and then a times the square root of 2, so adjacent over hypotenuse would reduce to 1 over rad 2. And my tangent function of 240, so 240 would be here, and I would have a reference angle of 60 degrees. So my triangle would be 30, 60, 90. And my tangent would be opposite over adjacent, which would simplify to square root of 3. Since both my x and my y are negative, my tangent would reduce to a positive value. All right, we're going to move on to part 2. So we're going to find the value of another trig function given a trig function's value. So I have this angle theta. I know that theta is somewhere in quadrant 3. So my angle starts on the positive x-axis and ends somewhere over here. I don't know what that angle is, but I do know that the tangent of that angle is 2/3. So if I draw a right triangle, the relationship of the opposite side to my adjacent side is 2/3. Now, since my y values are negative, this is going to be a negative 2. X values are negative in quadrant 3, so this would be a negative 3. So negative 2 over negative 3 does reduce down to that positive 2/3. What we really care about is finding the cosine of this angle. Cosine is the adjacent side over my hypotenuse, so I know that I'm going to have negative 3 over some value, but I need to find the value of that hypotenuse. So I go a squared plus b squared is equal to my hypotenuse squared. 9 plus 4 is 13, which means that my hypotenuse is the square root of 13. Since this is just a distance, we are not talking about an x or a y component, my hypotenuse stays just positive square root of 13. So my cosine is equal to negative 3 over the square root of 13 in quadrant 3. All right, go ahead and pause the video and see if you can complete these 2 on your own. Here I've got an angle theta that's in quadrant 4, so I start at that positive x-axis, and here's my angle theta, which means that I'm actually going to be using this reference angle after I make my right triangle. So cosine of that reference angle is going to be 1/2, so the adjacent side is 1, and my hypotenuse is 2. So I use that to go ahead and find my opposite side. I'm going to go ahead and call this y, since we are talking about a y value. Using my Pythagorean theorem, 1 squared plus y squared is equal to 2 squared, so y squared is equal to 3, which means that y is going to equal the square root of 3. Since we are in that fourth quadrant, y is negative, giving me a sine value, negative square root of 3 over 2. And to check number 2, our answer for number 2 should be positive 7 over 13 rad 2. That brings us to the end of part 2 of our summary video. Thanks for watching.